all about solving rational equations. What we want to do is solve for x. So unlike yesterday where we were adding, subtracting fractions, add a fraction, you're going to get a fraction for an answer, so we're going to be keeping the denominators. Now our goal is to get rid of the fractions. We don't want fractions anymore. We want to be able to solve the equation, so when we get to the very bottom line, we should be able to say x equals something, x equals 2, whatever. And then must check your answer every single time. Write that down, put a box around it. You must check your answer every time. Now, there's two types of equations you're going to see. Method number one. If you have a situation with just one fraction on the left and one fraction on the right, these are the easiest ones to solve. All you need to do is cross multiply. 7 times 2x minus 10 can be set equal to 11 times x minus 2. Then it's just a simple solving. 14x minus 70 equals 11x minus 22. Get your x's on the same side. 3x minus 70 equals negative 22. Add 70 to both sides and divide. X equals 16. But I don't know if this is true or not until I check this. So off on the side someplace, and this has to be a written check, you can't just do it in your head. 7 over 16 minus 2, does that equal 11 over 2 times 16 minus 10? 7 over 14, that's 1/2. Does this equal 11 over 32 minus 10 is 22? 11 over 22, yes, 1/2 equals 1/2. But remember now, 1/2 is not the answer. X equals 16 is the answer to the question. So that's what we're trying to do here. We're trying to get an answer, like I mentioned up here, we're trying to get an answer that says x equals something. That will be our solution. So this is different than yesterday, where I start with a fraction, add a fraction, I get a fraction when we're done. All right, method number 2. If you do not have just one term on the left and one term on the right, see here you've got 2 terms on the left. What we need to do is look for a common denominator. Just like we did when we were adding or subtracting our fractions, we were looking for a common denominator. What we need to do is take that denominator and multiply it by the entire equation, the whole equation. So we need to find a common denominator. We're going to multiply once on the left side of the equation, once on the right side of the equation. And again, our goal is to get rid of the bottoms, get rid of the denominators. All right, so if I check out the denominators, I need to figure out what is my common denominator. X to the first, x to the first. I always take whatever power, the higher power that I see. That's just x to the first. I've got a 5, I have to use the 5. So 5x should be my common denominator. What do I do with that 5x? I'm going to multiply the entire equation by 5x. Now remember yesterday with fractions, we multiplied once in the top and then in the bottom. We're trying to build up. Well, we don't multiply top and bottom anymore. What we do is multiply once on the left and we multiply once on the right. Remember, whatever I do on the left side, I have to do the same thing on the right-hand side. Another way that some people will write this, and I'm fine with that, 15 over x plus 4/5 equals 7 over x. Make one great big huge bracket, put your 5x out here, and you're doing a distribution. Once, twice, and 3 times, which would be on the other side of the equation. So either way, just make sure you're multiplying everywhere. Okay, so what's this going to look like when I do my distribution? 5x times 15, but I'm dividing out the x. So the x is gone. I'm only left with 5 times 15. 5x times 4, but I'm dividing out the 5. So again, the 5 will disappear. I'm left with x times 4. That's 4x. And on this side, 5x times 7, but I'm dividing out the x. Leaves me with 7 times 5, 35. And now we have a simple equation that we can solve. Leave the 4x here, let's move the 75 to the other side. 4x equals negative 40, and x equals negative 10. Now I need to check this to see if this is going to be correct or not. 15 over negative 10 plus 4/5, does this equal 7 over negative 10? 4/5, I can't add these two together yet because 4/5 is not the same denominator as 10. So let's build up 4/5. That would be 8/10. 5 over negative 10 plus 8 over 10. This negative sign, remember, can go anywhere. I can put it in the top or the bottom, so let's just slide it up there. Negative 15 plus 8, negative 7 over 10 on the other side. 7, negative 10, negative sign is in there once. Those are both the same thing. Negative 7/10 equals negative 7/10. So yes, x equals negative 10 is the correct solution. Number 2. Again, we've got three terms here. 12 over x plus 7 equals 1 minus 12 over x. X plus 7 is a quantity. When I see quantities, I have to use the whole quantity. So my common denominator, so far I've got x plus 7, and then I've got this plain x, I have to use that as well. So there is my common denominator, x times x plus 7. All right, so what are we going to do with that common denominator? We're going to multiply everywhere the whole thing by that common denominator of x plus 7. I'm just going to make my one great big bracket over the entire equation. And I'll do distribution 3 times. X plus 7 times 12, but I'm dividing out the x plus 7. So that x plus 7 would be gone, which is leaving me with 12x. Now start over. X plus 7 times 1 is exactly that, x plus 7. Minus, start over again, x plus 7 times 12, but I'm taking out the x. So the x will be gone, leaving me with x plus 7 times the 12. Looks like that. Now I can do some distribution here. 12x equals x squared plus 7x minus 12x, and be careful here, negative 12 times 7, negative 84. Now everything needs to get to the same sides, so I can factor this. Let's move the 12x over. X squared minus 5x minus 12x minus 84. 0 equals x squared minus 17x minus 84. This now has to factor. Two numbers that multiply to give me negative 84, that would add to give me negative 17. 21 and 4. X minus 21, x plus 4, and if I solve each one of those, my answers would be 21 and negative 4. But I don't know for sure until I check, and I'm going to have to check both of these. Let's start with the 21. 12 over 21 plus 7 equals 1 minus 12 over 21. 12 over, this would be 28. Does that equal 1 minus 12 over 21? Let's change the 12 into 21 over 21. 21 over 21 minus 12 over 21 would be 9 over 21. Let's see if those two reduce to give me the same thing. 12 and 28. What goes into both of those? 4. 4 goes 3, 4 goes 7, and then 9 over 21. What goes into both of those? 3. 3 goes 3 times and 7 times. So 3/7 equals 3/7. So yes, x equals 21 is one of my solutions. Now I need to check the negative 4. 12 over negative 4 plus 7. Does that equal 1 minus 12 over negative 4? 12 over negative 4 plus 7 would be 3. Does 12 over 3, which is 4, equal 1 minus, I've got a minus minus, so that's going to become a plus plus. 12 over 4 is 3. 1 plus 3 is 4. 4 equals 4. So I do have two solutions here, x equals 21 and x equals -4. All right, our last one, 7 over x minus 1 minus 5 equals 6 over x squared minus 1. Now before I pick out a common denominator for this, I need to factor this right-hand side. X minus 1, x plus 1, difference of two squares. So now when I pick my common denominator, I've got a quantity of x minus 1. I need to use that. That's a matching quantity. And I've got another quantity of x plus 1. So my common denominator will be x minus 1, x plus 1, which remember is just x squared minus 1. Okay, so let's get that out of there for the time being. And we'll put our big parenthesis multiplying by x minus 1, x plus 1. Distribution first time, the x minus 1's would cancel, which leaves me with 7 x plus 1 minus all of this times 5, nothing will cancel, and so I'm going to just write it as the quantity of x squared minus 1, since that's what both of that is, x squared minus 1, equals, now this whole thing times 6, but then I'm going to divide out the x squared minus 1, so they're both gone, which leaves me with just my 6. All right, distribution, 7x plus 7 minus 5x squared plus 5 equals 6. I'm going to move everything over to the other side. I want this x squared to be positive. 0 equals. So the 5x squared is over here. 7x is going to end up negative. Plus 7 plus 5, there's 12, but I subtract the 12 from both sides, should leave me with a minus 6, equals 0. Now we have to factor by grouping. Two numbers that multiplied, 5 times negative 30. Two numbers that multiply to give us negative 30, that would add to give us a negative 7, negative 10, and 3. So I'll separate this now. 5x squared minus 10x plus 3x minus 6 equals 0. Cut it in half and factor by grouping. 5x, x minus 2, plus 3, x minus 2, 5x plus 3 times x minus 2. And when I take each of those out, I'll get positive 2, and on this side, negative 3/5. All right, now, let's check the easy one first. Let's check the 2 first. 7 over 2 minus 1. Subtract 5. Does that equal 6 over 2 squared minus 1? 7 over 5, or excuse me, 7 over 1 minus 5, that's 7. 7 minus 5 is 2. 6 over 4 minus 1, 6 over 3, that's 2. 2 equals 2. Yes, that checked. 2 is one of my solutions. All right, now we're going to check the second one. I'm going to get rid of all of this right here so I have some room again. And the number we're checking this time is negative 3/5. This is going to be a fractional check, so this one's going to be kind of messy. 7 over negative 3/5 minus 1. Subtract 5. Does this equal 6 over negative 3/5 squared minus 1? All right, let's start down here in the bottom. Negative 3/5 minus 1. I'm going to change this minus 1 into minus 5/5. Negative 3/5 minus 5/5 is negative 8/5. Dividing by a fraction is the same as multiplying by the reciprocal, so I'm going to be multiplying 7 times 5 over negative 8. That's negative 35/8. And I'm subtracting 5 from all of this. Now 5 is really 5 over 1, but I need to be in eighths, so let's make this 5 into timesing by 8, negative 40 over 8. So I have negative 35 over 8 minus 40 over 8, negative 75 over 8. All right, that's the left-hand side. I told you it'd be ugly. Okay, over here, negative 3/5 squared. Negative squared would be positive. 6 over 9/25 minus 1. But since I'm in 25ths, let's change this right now into 25/25ths. 9/25ths minus 25/25ths should be negative 16/25ths. 6 over negative 16/25ths. Dividing by a fraction, same as multiplying by a reciprocal. 6 times by negative 25/16. 6 times negative 150, or excuse me, 6 times negative 25 is negative 150/16, and 150/16, divide that in half, negative 75/8 equals negative 75/8. Yuck. So yes, both of these work. Yes, you have to check all of your answers. Yes, you need to write it down. You can't just do it in your head. Obviously, doing it in your head with ugly things like 3/5 is not an easy thing to do. So the check is part of the solution. Have to show your check in order to get your full credit. All right, I do believe that is it. Yes, that is it. Okay, so remember, in this section, 8.6, you are solving the equation. Your goal, get rid of the fraction. You want it to have x equals, when you're done, as your solution. And don't forget the check.